Okay, so if the left end is in simple harmonic motion here, and I do y of 0t to indicate that the motion of the left end is a function of t, right? And that occurs when x equals 0. So y is really a function of two variables. Okay? So up here I've talked about y of x at a point. We can do that, right? And I could have said this is y of t at the point x equals 0, but easier to write it this way. Because now I can write y of xt and get a general solution for y of xt. Well, what happens at x at x equals 0 happens at position x after a delay of x over c, which is a time interval, time it takes to get from here to there, right? So y of xt equals a times the sine of omega times t minus x over c. Okay? So now we have a function of x and t that gives you a snapshot of what happens to every point at every time. Okay? And if I want to hold x constant, which we're kind of doing here, x is some specific position, this is the simple harmonic motion of that point. Okay? And that simple harmonic motion has the same angular frequency as the left end where you're driving it. Okay? But it happens at a different time, which means it's out of phase. It means if this thing's doing this, you know, it starts from 0, goes up, down, and up. This one doesn't start from y equals 0. It starts maybe up here. So as this one goes up, it reaches its peak before this one, and they're kind of out of phase. They are out of phase, and the phase difference is omega times x over c. Okay? Now, I said that, but you're asking some questions to work that out. Okay? And what we mean by phase difference, well, we're going to get to that. Okay? So that's one characterization of this traveling wave. Another characterization is that we can take a snapshot of the wave at any time. Right? If the time is fixed, then this is just a position of x, and that gives you a graph of the wave at that time. Okay? So if you hold x fixed, you get the simple harmonic motion, formula for simple harmonic motion at that position, which will be in some relative phase to the simple harmonic motion at the left end. And if you hold t constant, well, that gives you the shape of the wave, the y versus x shape of the wave. And it's going to be a sine wave, but you need to work that out and get used to the idea.